Hey, welcome back. In this video, we're going to be looking at the area of similar objects coming up. So let's look at an example. We have a rectangle, length of A, width of B, and we're going to enlarge it by a scale factor of K. If we're going to do that, then we're going to increase the length of A by a factor of K and also increase the width of B by a scale factor of K. So if the sides of the rectangle are multiplied by K, a similar rectangle is obtained. Similar means that both of the shapes have the same angle property and the same length ratio property. If you need more help on similar figures of similar shapes, go and watch my playlist that I'll attach in the YouTube cards bar or in the description below. So the area of my original shape, the object, is going to be A times B, so AB. And the area for the new shape, my image, is going to be K times A multiplied by K times B. We can rewrite that as K squared times AB. Or further, we can actually establish that that's K squared, so the scale factor squared, times the old area. So the original area times by the scale factor squared. The reason the scale factor is squared is obviously because this is a length times a width, so it's K times K makes K squared. So what if we had circles? Well, if the radius of a circle is multiplied by K, a similar circle is obtained. If we increase the original object by a scale factor of K, then we increase this circle, this image, by K times R, K times the radius. Now, the area for the original circle is pi r squared. The new area is going to be pi times kr squared. Now we can separate the k and the r by saying k squared r squared. And we can further rewrite this by saying k squared is equal to pi r squared. And yeah, you may have guessed it, that's k squared times the old area. So the original area, pi r squared, and then we multiply that by the scale factor squared to get the new area. So a rule of thumb, if an object or figure is enlarged by a scale factor of k, then the area of the image is equal to k squared times the area of the object. So let's do an example then. We have a triangle ABC which has an area of 1.5 meters squared and a side length of AC 2 meters. We have a similar triangle PQR that has a corresponding side length PR of 2.8 meters. So the question is, what is the area of triangle PQR? If we enlarge triangle ABC to make triangle PQR, what we're trying to do is find the scale factor. So we can do that by taking this length of the image divided by the corresponding length of the object. So 2.8 divided by 2 will give us a scale factor of 1.4. So basically what we're saying is triangle PQR is an enlargement of triangle ABC by a scale factor of 1.4. So now we can use that scale factor to work at the area of PQR. The area of PQR is equal to K squared times the area of ABC. This is the original triangle. So therefore we do 1.4 squared times by 1.5, and they gave us that information that 1.5 square meters was the area of ABC. And if you do that on your calculator, then you'll get the value of 2.94 meters squared. So the area of triangle PQR is equal to 2.94 meters squared. Let's look at another example where we find out the surface area of the sphere. Sphere A has a radius of 4 and sphere B has a radius of r. The two spheres have surface area of 201 centimeters squared and 452 centimeters squared respectively. Find the radius of the larger sphere. Pause the video here and attempt the question by yourself. You may have worked it out like this. So if we enlarge A onto B, the area of B is equal to K squared times the area of A. Since we know that the area of B is 452, that's equal to K squared times the area of A, which is 201. We can rearrange this to make K squared the subject as 452 over 201 equals K squared. Then, provided that K is greater than 0, the square root of 452 over 201 will give us a value of roughly 1.50. Now to find the radius, we can do K times 4 because we know that 4 is the original radius of sphere A. So the radius is equal to 1.5 times 4, which roughly gives us a radius of 6.00. So B has a radius of 6 centimeters. I hope that's what you've got. If you haven't, make sure you pause the video and you make sufficient notes in your copybook. In the next video, I'll be doing the volume of similar objects. So make sure you watch that one. Thanks for watching. I'll see you in the next one.